Black holes are volumes of space where gravity is extreme enough to prevent the escape of even the fastest moving particles. Not even light can break free, hence the name black hole. Now let's talk about how they form. It's generally accepted that stars with a mass of at least 3 times greater than that of our suns can undergo extreme gravitational collapse once their fuel depletes. With so much mass in a confined volume, the collective force of gravity overcomes the rule that usually keeps the building blocks of atoms from occupying the same space. All this density creates a black hole. Now let's talk about the types of black holes. We know of 3 types of black holes. The first is the so-called stellar mass black hole. These are remnants of huge stars when, at the end of its life, a star with more than 5 times the mass of our Sun explodes as a supernova. Gravity compresses its core suddenly and violently. Depending on the star's mass, collapse may halt and form a neutron star, but if its mass is sufficient, the core's collapse will continue, forming a black hole. Stellar mass black holes have masses ranging from a minimum of about 5 times the mass of our Sun up to about 60 times the Sun's mass. Their diameter is typically 10 and 30 miles. Intermediate black holes. Scientists announced the discovery of an intermediate mass black hole in 2021. This type of black hole bridges the gap between smaller stellar mass black holes and supermassive black holes that lurk at the center of galaxies. The newly discovered Goldilocks black hole has a mass of 55,000 suns. The astronomers found the intermediate black hole by detecting something located far behind it, the signals from a gamma ray burst. The gravitational lensing of the burst emission clued scientists into the intermediate mass black hole. Last but not least, the third type of black hole is the supermassive black hole. These can have the mass of billions of suns. Astronomers believe that most galaxies have supermassive black holes at their cores. The one at the center of our own Milky Way galaxy, Sagittarius A, has some 4 million times our Sun's mass and is some 37 million miles in diameter. Now let's talk about white holes. A white hole is a bizarre cosmic object which is intensely bright and from which matter gushes rather than disappears. In other words, it's the exact opposite of a black hole. But unlike black holes, there's no consensus about whether white holes exist or how they be formed. A white hole rather repels objects, unlike black holes, the exact opposite of black holes.